These are my disclosures, but not related to the talk today. So I'd like to thank the previous speakers from the other session, Trinity, for the overview. I think we're all familiar, especially at this point, with the normal physiological process of erection, but just to go over this again, it involves a lot of different systems. So we know that there's involvement of the neural system, vascular system, endocrine systems. Starts with physical or psychological stimulation and neurotransmitter release. We've talked about nitric oxide and how it's released and its ability to activate this cyclase, increase cyclic GMP, and also act as a vasodilator. Cyclic GMP relaxes the smooth muscle, increases blood flow, so along with the vasodilation, leads to an erection, and then we know that erection ends in part through PDE5, which breaks down cyclic GMP, leading to detumescence. So if we just look broadly at this overview of the process of erection, we can see that there's a lot of places where there can be dysregulation or inhibition of our ability to create and maintain an erection. So you can have dysregulation in any one of these systems with the muscles, with the vasculature, neurotransmitters, things like that. And so that leads us to the point that ED pathogenesis is complex. So, you know, these debates are kind of geared towards, is it this or that? Calvin, I'm going to call a truce here and say that there's probably not an answer to this. So ED pathogenesis could be psychogenic, neurogenic, involve the endocrine system, arteriogenic, venogenic, as Trinity just talked about. Can deal with smooth muscle activity, although I will say that underlying muscle activity, you're going to rely on neural signals for the initiation of that, and that even in healthy vascular systems, nerve damage can prevent the initiation of erection. In addition to what kind of underlying lies the pathogenesis, it's what can contribute to that. Is it genetic components, epigenetic components? There is evidence to suggest that at least a subset of ED is related to genetics or heredity. So today I just want to talk about the neural or neurogenic possibility of pathogenesis for ED, and I'm going to do that by looking at different central nervous system disease states and how that might impact erectile dysfunction. So just a quick overview of neural control of erection. We know that it involves both the central and the peripheral nervous systems, that the brain can initiate and maintain erections through stimuli. Those can be visual, auditory, tactile, imaginative. There's a lot of interplay with different areas of the forebrain and brainstem, which I'll talk about in just a second. And then we also know that there is involvement in the peripheral nervous system, particularly with the interplay of the parasympathetic and sympathetic nerve systems controlling the initiation of the erection, release of nitric oxide, and then controlling detumescence. There's also the complexity of a lot of different neurotransmitters which are involved in this process. So dopamine going to the reward centers of the brain, serotonin plays an inhibitory role in erection. So we know that people with SSRI inhibitors or SSRI antidepressants can have reductions in libido and erectile function, and then acetylcholine being a major facilitator of nitric oxide release, just to name a few. So if we look at the involvement of the central nervous system, we know that there's a lot of different areas of the central nervous system that are involved in sexual arousal. So this is a study looking at fMRI images in patients that were watching erotic videos. We see that there's involvement of areas such as the prefrontal cortex, the thalamus, the amygdala, the hypothalamus. And then I won't go through this table, but it kind of gives an idea that there's a lot of complexity with a lot of different areas of the central nervous system, either through activation or inhibition in the process of sexual arousal. So there's a lot of intercommunication between forebrain areas and the hypothalamus, subsequently the brainstem, and then down through the spinal cord. And then there's the constant interplay of input and output signals in the sympathetic and parasympathetic nervous systems. All of this is to say that this is a very complicated system with a lot of opportunity for dysregulation. So let's look at a couple particular central nervous system disorders and whether or not they influence erectile dysfunction. So we know that ED is associated with direct nerve injury. That makes sense. If you impact the nerves that directly innervate the penis, you're going to have problems with erections. So spinal cord injury is somewhat dependent on the level of the injury. Reflex erections can be mediated through the parasympathetic and sympathetic nervous systems. Typically, these spinal neurons are maintained in S2 through S4, so if you have higher spinal cord injuries, you're able to preserve those reflex erections, but you lose the ability for the psychogenic erections because of that severance to the central nervous system. We also know that radical prostatectomy, when there is very commonly injury to the cavernosal nerve, that the rates of erectile dysfunction can be extremely high as 87%. And even in quote-unquote nerve-sparing radical prostatectomy, you can see ED rates as high as close to 80%. So this makes sense. Direct injury to the nerve is going to cause issues. What about when you're not directly injuring a nerve? So if we look at studies with stroke patients, so there's a review looking at 20 studies of stroke, looking at over 3,000 stroke events. They found that the relative risk of erectile dysfunction in stroke patients was 3 times higher than in non-stroke patients, that 32 to 78% of these post-stroke patients had erectile dysfunction. Now, you could say with stroke, that could be neurologic underpinning that, or with stroke, you could have some psychological impacts. And then obviously there's evidence to suggest that there could be some vascular changes or damage there that would lead to erectile dysfunction in those patients. So how about not diseases that aren't so related to the vascular system if we look at tumors? So studies looking at brain tumors in general, primarily these men had glioblastomas or meningiomas, found that 60% of these men had ED, and the average age for these men was 54, so it wasn't a very geriatric population that had this higher incidence of ED. If we look at central nervous system movement disorders as well, and Parkinson's disease, if we review studies there, there's a review of 3 studies looking at sexual function in men with Parkinson's disease, found that 54 to 79% of these men had erectile dysfunction. If we looked at an age-matched study with men with Parkinson's disease, it found that 60% had erectile dysfunction compared to 38% of matched controls. If we look at multiple sclerosis, another movement disorder, reported rates of erectile dysfunction in these men have been reported to be as high as 91%. So all of this suggests that these disorders of the central nervous system can have a direct correlation to erectile dysfunction. Now, movement disorders, you could say, okay, there's involvement of musculature as well. So let's look at non-movement disorders with Alzheimer's disease. There was a GWAS study that looked at over 40,000 patients with Alzheimer's and then 40,000 controls, and found that Alzheimer's disease was a significant risk factor for erectile dysfunction. When they did the reverse analysis, erectile dysfunction was not causative to Alzheimer's disease. So the association with Alzheimer's and erectile dysfunction maintained or persisted even after controlling for cardiovascular disease, suggesting that this was more neurologic. If you look at dementia, an insurance database study looking or following 4,080 patients and 20,000 plus controls over 7 years found that those that had erectile dysfunction at the end of the day were at higher risk of developing dementia. Similar study looked, using the Vietnam-era twin study of aging, found that men with erectile dysfunction had significantly lower cognitive abilities even after controlling for covariates such as age and health factors. So we talk a lot about erectile dysfunction being an indicator of cardiovascular health, but these studies would suggest that it is also an indicator of cognitive health. And then one of the more impactful studies, so this was done by Dr. Wessel's group in the University of Washington, did a large GWAS study using the Kaiser Permanente Adult Health and Aging cohort, and then they replicated their findings using the UK Biobank, which has genomic data for over 200,000 patients. And what they found was that there was a single locus that was identified in chromosome 6 that was significantly associated with erectile dysfunction. This locus was found to be associated with the gene and gene promoter related to SIM1. So what is SIM1? SIM1 is single-minded 1, and where is it expressed in the central nervous system? So paraventricular nucleus of the hypothalamus, the amygdala, lateral hypothalamic areas. It's known to play a role in the leptin melanocortin pathway, and which we know releases peptides such as alpha MSH and ACTH, which when injected are known to cause erections in men. So all of this is to say, so this GWAS study looked at or found a single gene that was involved in erectile dysfunction, and that gene is not expressed in the vasculature, but in the cortical regions. So can ED development be linked to neural control? These studies would suggest that yes, it can be, that there's a number of cognitive disorders that are associated with erectile dysfunction, suggesting a neurological underpinning. Is neural control the only thing that leads to ED development? Unknown. I'm sure that Calvin is going to argue otherwise, and I think that that's probably true, that there's a lot of pathophysiology that's not directly related to neural control, but I would suggest that further research into the neural underpinnings of these other pathophysiologies is warranted, and that we might be looking a little too superficial at what is controlling ED development. Thanks.